It's 7:30. I think we'll kick off. I'll try and mute everybody. If I can manage how to do that.
Yeah.
Mute all. Okay. Hopefully you can hear me, and hopefully you can see my screen. So if you can hear me and see my screen, just okay. Oh, Alistair, good evening. We've got Alistair here from Stockholm, who's been supervising some of this work. So it'd be interesting to get his thoughts on this. Okay, so we're going to kick off. Let's go to Islay. So someone asked how we get to Islay. Most of you know this by now, but it's over on the west, west of Glasgow a little bit, near Ireland. Get to it from Kennaicraig or from Oban to Port Ellen and Port Ascaig. So we're way out in the western, southwest Hebrides. Okay, so you all know where we are. Let's have a look at a geological map. Excuse me, that I am looking to my left, your right, because I've got two screens here, so I can see all you good people on the right hand side, and I can see my screen on the left. So if I'm looking over here, I'm not looking, I'm trying to actually, and I've got my chat line, the chat up on my right hand screen as well. So hopefully we can see all that. This, I don't know why that red line appeared. Oops, I just have to go back. I must have hit the annotation button by mistake. I have drawn that is almost a Loch Grignard, well, part of the Loch Grignard. I don't know what that red line is. Ignore the red line. Okay, so we're going to be looking at this part of Islay, the southern Rhinns. The Rhinns Peninsula is this bit of Islay, separated from the main part of the Dalradian of the Islay succession by the Loch Grignard fault, which runs up here, and up past Colonsay, which is Colonsay here, and up past. So we're looking at the Rhinns Complex, which is at the sort of base of the geological succession over here, and looking at the Colonsay Group, which is marked in green, extending in the north part of the Rhinns and under the sea to Colonsay as well. And there's a tiny bit of Rhinns Complex up in the top there, but I am going to not mention that one. I'm going to just talk a little bit about, well, the evening talk is all about this area, the southern part of Islay, from Bruichladdich in the north here down to Portnahaven via Fort Charlotte and the sort of western coast. I'm going to do a tour of this area, and we're going to look at the Rhinns Complex itself and then concentrate a little bit. Most of the talk will be about the contact between it and the Colonsay Group, the sort of the boundary between the red and the green, as it were, in this part of the world here. So the Rhinns Complex overlain by the Colonsay Group, which is, I've written here, arguably part of the lower part of the Dalradian. Now we'll discuss some of the evidence for and against that correlation, and then obviously the main part of the Dalradian, Appin and Argyll groups are over on this side of the island. So let's head off this away. So now I'm going to have to get rid of this annotation, these lines, which I seem to have drawn by mistake. And I don't know how to do this. Oh dear. Right, I'm going to have to get rid of these lines somehow. I'm going to have to just...
David, I think if you go into drawing, there's a clear all option.
Into what, sorry, Roy?
Drawing tools up at the top, select drawing tools.
Yeah, I've done it, yes, I've done it in... Oh, it's annotate here, annotate.
It doesn't really matter, actually. Just carry on if I were you.
I've got it. Just to show I am technically advanced. Thank you, Roy. Right, let's go back to the slide. Let's go back to, right. Okay, I won't touch anything that I'm not supposed to touch. Okay, so we're going to head around around the southern Rhinns in a sort of clockwise fashion, and then double back on ourselves. We're going to start in Bruichladdich, and we're going to go down to Portnahaven and Loch Glossop Bay here, and then to Kilkieran to look at the Rhinns Complex without any complications of the cover or the Colonsay Group cover. Then we're going to discuss. I'm going to discuss a little bit about I'm going to put this pointer onto a laser pointer. That might be easier. Yeah, and then I'm going to cover go back. We're going to go back round again to look at some of the outcrops and exposures where the cover basement contact is exposed. So that's the basic plan of the evening. So here we are starting at Bruichladdich. I am sitting up here, just looking down on the distillery as I speak. So yeah, and it's just about lovely day today, looking down on Bruichladdich. What's interesting here is the rocks on the foreshore here, and we'll have a look at those. This is traditional, a slide I show to everybody pretty much to sort of show the two key rock types of the Rhinns Complex. This is an introduction to the Rhinns Complex. We have a significant chunk of the Rhinns Complex is this sort of orangey pink sort of cyanitic gneiss. In a polished, well, a pebble from the beach, it looks like this. A lot of pink orthoclase, a lot of perthites and microclines in that, and a sort of cruddy mixture of mafics, sort of mashed up hornblends and with some epidotes and biotites and stuff like that. Quite a lot of shearing fabrics in it as well. It's not, but it's a sort of crude gneiss foliation where you see it in outcrop like this. And then 30% of the Rhinns complex seems to be composed of this sort of mottled dark green, light green metagabbro. Lots of saturatized feldspar and pyroxenes that have been that are now hornblende. So a metagabbro and a sort of cyanitic gneiss. They're the sort of red and the green apples, as I call them. That's the sort of traditional sort of lithologies that one finds. Though, as we'll see tonight, this isn't the only lithology. So when you read about the Rhinns complex, you think that this is all there is. There is a lot more than this. So here's the sort of pinkish cyanite in outcrop at Bruichladdich on the coast, and in thin section, as I've said, a lot of microcline, a lot of perthites, some tiny bits of quartz. Sort of, these are amphiboles here, and some biotite and some iron. A lot of the sort of the pink color is actually a staining around in plain polarized light. There's a lot of iron and hematite and dolomitic staining around some of the crystals as well. So it's maybe some of the color is a bit more than just the traditional sort of pink feldspar. It's enhanced by a sort of later staining. The green metagabbro often looks like this. Sometimes it's sort of, you can see some of the sort of crystals in it. It's quite coarse. Other times it's much finer. There may be multiple phases of intrusions. There may be multiple phases of deformation going on in here. But this is traditionally what this looks like in outcrop, the sort of green metagabbro. This is at Bruichladdich as well. And in thin section, here's some X-pyroxenes, now amphibole, a lot of some biotite. These are the feldspars completely messed up, saturatized, as I said. And yeah, so this is a fairly typical thin section of the metagabbro, but quite coarse. Obviously, it had quite, we can think of its protolith as gabbroic, because some of the original phenocrysts are sort of preserved. They're quite large. So it's a metagabbro is a decent enough term for it. And what's the relationship between them? And it's often very difficult to see a relationship between them. This little bit of exposure here has the sort of cyanitic gneiss with some mafic sort of compositional banding going on in here, sort of mafics and felsic sort of bands, or a bit haphazard. Hard to just distinguish a particular dominant foliation direction in it, but this is the gneiss texture in the gneiss. And then you've got the metagabbro here with a contact here, seemingly a contact running through here somewhere. And most of the time when you see it, that any sort of crude foliation in the metagabbro is not the same as the gneiss foliation. So it's believed that the metagabbro is later than the gneiss formation. So we've got a cyanite protolith, which underwent a gneiss deformation event, and was followed by intrusion of gabbro, which was then, all of that was then metamorphosed. Yeah, so we can see two distinct sort of metamorphic events and two distinct igneous events already that we've seen in the exposures so far. Quite a lot of the metagabbro is quite foliated. That the previous exposure wasn't, but most of it, quite a lot of it, looks like this, with a sort of quite a strong, pronounced foliation. Obviously, because it's mafic rich, it tends to shear more than the felsic rocks. So often this gets very sheared, and we'll see quite a few examples of this as we go further on. And some of the syenite is quite sheared. This is quite a sort of alga gneiss type features that we find there as well, with these large pink feldspars when we get this compositional banding, and there's obviously a lot of shearing going on. So it's not a simple story. We've got igneous events, metamorphic events, and some sort of shearing which seems to affect both of them. So we're already into a complexity of metamorphic and igneous events, and we haven't even left Bruichladdich yet. So we're going to go down and see some more of the Rhinns complex down at Portnahaven, a lovely little picturesque village down the southwest tip of Islay. Many of you have probably been there. These islands offshore here with the lighthouse, and the wave generator site up by Curry Sands is a nice place to go and look at some different rocks. So here's picturesque Portnahaven, nice pink syenites on the beach here, metagabbros if you walk around the corner. So you can see the same sort of rocks that you see at Bruichladdich just here. But at the wave generator site, there's Portnahaven in the distance there. There's the island of Orsay with its Stevenson lighthouse on it. And this is the old Limpet wave generator site. It's now dismantled, but the main concrete infrastructure is still there, though all the gubbins and generators have all gone now. But what's interesting is that all the rocks around here are quite white, yeah, quite pale colored rocks, not pink, not green, nothing like that at all. And you can see, even just standing on these rocks here, they're quite white, white coloured, and there's a lot of quite a sort of foliation in this, which is, though I haven't put a compass on this here in the picture, it's running southwest northeast. Yeah. And here is in sort of, when you pick up some of those white rocks, you see these very, very, very strongly sheared rocks. A lot of shearing going on in here. You can see these sort of almost these flazer type cataclasic textures in here. And when you pick up these rocks, it's soapy. This is talc. There's a lot of talc in this, and it's probably a very, very deformed ultra basic rock of some description. Has eyes of some of the rock that hasn't been foliated in it here, and little epidote veins as well. And then there's a lot of epidote kicking around in here. So we've got this quite a pronounced shearing event going on here, and some quite big in the felsic pods. We seem to get pods of felsic materials left as sort of huge algons, basically, in this sheared ultramafic set of rocks, with great big epidote veins in them here, and some chrysotile. This is the shearing. There's some darker rocks here. You can see there's very, very strong foliation. Again, all this foliation tends to be subvertical and trending north, east, southwest, i.e. the sort of sense, almost a Caledonian trend, to be honest. And we can, what we'll debate this evening is whether that is Caledonian shearing or not, because that's just because it's the same trend as the Caledonian doesn't mean to say it is, in my opinion. But let's go on further around the coast. You get even more shearing. This is probably the sheared. These examples here are probably the sheared metagabbro. It's been mapped here as a I can never pronounce it. Philonite. It's almost a schistose sort of rock, but it's actually incredibly sheared. So yeah, some mega deformation going on in some of these rocks. So that was where we were, just there, and we'll cruise around to Losset Bay and have a look at Losset Bay very quickly, just to get a handle on it. What you can see here, this Losset Bay is just coming up around here, but this is a view taken to the south. It's quite an obvious sort of, all this is syenitic gneiss, but you can see here there is quite a sort of northwest dipping. This is out to the sea, sort of crude foliation in it. But there's a microscopic foliation in these things, but there's also on a megascopic scale. It's quite broken into these into almost this slabby sort of, you would think it was sort of big beds of sandstone from a distance, but it's igneous rock. It's all metasyenite. As you get closer, you can see these are the metasyenites here on the sand, on the edge of the sand here. And when you cruise down into here, you see that here's the banded gneiss with its sort of mafic, thin little mafic stringers and things in it, microlithons of mafic material in here. and over here. But then in here we've got this, here's the Metagabbro, with its sort of large green feldspars, the soritized feldspar, and arguably a sort of chilled margin as well here. So you can see there's an isofoliation in here, which is all sort of cut by this, but this seems to have come along the foliation, as it were. It's used the foliation as a plane of weakness on the intrusion of this dolerite gabbro rock that's intruded into the syenite. Then having thought it was easy, you go and see an outcrop like this and an exposure like this, and you think, well, what is going on? So here's the syenite, but there's a dark sort of ultramafic sort of rock here. There's some orangey pegmatites stuck in here. A very complex arrangement of these rocks here. There's something going on here, but it seems to be cut by this, which maybe goes there. Then maybe this is the other edge of the intrusion. So you've got this intrusion in here into that. But the foliation direction was this way, but this intrusion seems to be dipping the other way. So again, sort of complexities start to generate themselves here. And when you're around the corner, there's the pegmatite net veining this ultramafic rock, which is entirely hornblende. It's some sort of original pyroxenite type rock, probably. But I think there's some serpentine as well, so maybe an olivine pyroxene rock, and it's now mainly hornblende and serpentine, and with these net veins of pegmatite going through it, and the syenite and the metagabbro all seem to be messed up as well. So a bit difficult to sort of get a handle on what's going on here. Anyway, the whole story of the Rhinns complex is basically that the igneous rocks are believed to be the main metagabbro metasyenite are believed to be part of the sort of in-depth bathylitic intrusions of below a volcanic arc, which is dated about 1.8 billion years ago, a volcanic arc on the edge of the Columbia supercontinent. So here's northern Scotland, northern Rockall, Greenland, Baltic Shield, and a sort of arc. Some of the literature calls it the Malin arc, but it's a volcanic arc which seems to have extended all the way from Sweden and Norway right through to Greenland and Labrador. A sort of large mobile belt on the southern flank of this Columbian, southern as in current orientation, on the southern flank. And then at 1.7, which is the dating of hornblends in the metagabbro, has given us a date of 1.7 for the metamorphic event. So the metamorphic event is dated at 1.7 in the hornblends. It's a potassium argon date, and it arguably it's the metamorphism that's attributable to the accretion and the collision of this arc into the Columbia continent at 1.7. This is the same as the late Laxfordian. So the late Laxfordian deformation in the outer Hebrides here is probably the same age as this thing, and it's all very much related at 1.7 billion years. We've got the subduction, we've got evidence of the subduction in the Laxfordian, and evidence here of this collision. And you could argue that some of the debate is how much of that shearing, although we can date the metamorphic mineral growth in the hornblende at 1.7, how much of that shearing, which now has a Caledonian trend, how much of that shearing was related to this 1.7 billion year event, or was it Grampian, i.e. 470 million years? You know, so this is what we're going to have this is what some of the essence of what we're going to be talking about later on this evening. So this is just give you an introduction to the sort of the Rhinns complex as it stands, without any complications of its cover and its boundaries. So we'll head to Kilkieran Bay. We were here in Losset Bay just there, and we've now come sort of round the corner to Kilkieran, which is the first time we see in this trip, we'll see the boundary between the Rhinns and the Colonsay Group. So here's a nice, badly put together picture of a nice place. And here in the foreground here, we have a whole bunch of metasandstones, arkoses, belonging to the earliest, youngest, so the oldest part of the Colonsay Group that we see on this side of Islay. And they extend across, this bay is formed in some more mudstone rocks, and then there's more sandstones forming these fingers out in here, and they're dipping away from us. They're younging away from us, and they're dipping away from us in a sort of dipping away from us in a northwesterly direction here. And here's Alistair standing astride what I call the billion-year gap, because you've got 1.8 billion-year-old gneisses here on this side, a bit covered in usual sort of rubbishy vegetation and greasy stuff. And these are arcosic grits on this side of a fault zone. This is the Kilkieran shear zone. There's a couple of meters of very sheared rocks inside this fault gully, and you can see here it's dipping in a sort of fairly steeply to the northwest, and the beds here are slightly lower angle than the dip of the shear zone, and the shear zone seems to follow the dip of the foliation in those slabby sort of gneisses on the right hand side here. So that's where that picture was taken, and it's very obvious feature on the satellite photography, running right along the road here through that little gully there. Seems to be offset by a later fault, probably Mesozoic, possibly even tertiary movement on it, and then it carries on down the coast, separating the gneisses on the south side from the bedded arcosic grits here. And you can see these are the grits here that was just showing in the foreground of that panorama, and then you can see these other grits forming these fingers of rock out into here with these little bays, and these bays are where metamudstones where they've been quarried, and these bays have actually been enhanced a bit by man because they're quarried for slate. So these metamudstone bands, and the belief is that this system, these sequences of rock are deltaic, and they are representing sort of coarsening up cycles of mudstone, siltstone, sandstone, mudstone, siltstone, sandstone, of deltaic advances from the original grit, which may have been a fluviatile deposit. So this is the south of the bay. The shear zone is marked by this lovely sort of pebbly thing here, beaches with little tidal pools, and there's basically almost a double shear zone here. You've got shears on one on this side. This is the Rhinns Complex here, and on the other side is the grits here. Not obvious in this picture, but they are all dipping to the northwest out to sea. So here's my sort of geological map of the area. There's the shear zone in the gully that we were talking about where Alistair was standing. There's the dip of the rocks down here. It runs alongside the road here as the grit is the orange band of grit is offset by the fault. There's some lamprifiers intruded along the fault planes in places. There's the double fault plane and the little tidal pools down here. And the pink is the gneiss, undifferentiated. I've just called it the Rhinns Complex stuff. And then you've got a whole sequence of metamudstones, metasandstones in a sort of folded sort of sequence here. Some of these beds may be repeating. So they basically start off dipping and younging this way, but there's a sort of rucked carpet sort of fold structure going to the northwest, away from this fault zone. Here's some of the lithologies in the Colonsay Group. There's the slates, one of the slate quarries. This is the one nearest the road. It's quite steep. We've got a bedding parallel cleavage. When you look at the fine laminations in this, here there's just more mud in it, so there's less laminations. But it seems what laminations are vertical, but it sort of, as you go away, it sort of tends to flatten out. You get these laminated siltstones, some little sandstone beds, little lag gravels, some quite coarse arcosic gravels in places. This is a sort of correlation diagram that's been sort of drawn based on Claire McAteer's work. And this is what we're seeing here at the Kilkieran area, where we've got a Rhinns complex with the grit, then phyllites, so-called phyllites, but they're not really, they're just slates and metamudstones, sandstones, and then further north, there's much more in the way of turbidites, which correlate to Colonsay, and it seems to be that the upper part of the sequence carries on in Colonsay to the youngest bits we've got. What we're going to see on the other side is this bit over here, but this was drawn as an unconformity here, but the chart that what we are seeing is actually, I cannot see any evidence that other than that the contact is a fault of some description. Yeah, and this is the Kilkieran shear zone. So some of the original research called it a shear unconformity, but whether this is actually the basal unconformity, the jury's out for me. It's a fluviatile arcosic sandstone, but it's not a conglomerate in the sense of a basal conglomerate, which we're going to see in a minute. The folding to the north looks a bit like this. This is a typical sort of modeling thing of the sort of fault propagation folding. But we do tend to see a lot in Islay in these folds. There's a northwest verging fold with a sort of low deformation on the flank, a very, very pronounced deformation in the core of these inclined folds, asymmetric folds, and the tent verging to the northwest. So this tends to be the sort of the pattern that we get in the sort of the folding, and this sort of progressive deformation that you get as this fold propagates through the fault tip moving up there gives you a sort of progressive shear and a progressive fold developing, and that seems to be quite characteristic for the fold structures to the north. Let's go back into the shear zone, because this is where I really want to concentrate on. This is the nice. This is probably a bit of a metabasite here. It's pink, nice up here, and this is the green metabasite in here, and then this is the arcosic grit on this side. So the shearing seems to be in the Rhinns Complex lithology, not in the grit. It seems to be within the metabasite unit here. And you get these sort of textures. So you get this sort of streaking out of all the mafics and the felsics into sort of microlithons. You get this asymmetric sort of eyes. You could argue that this is demonstrating sinistral sense of shear, going that way. And you look at other exposures too, you get this again with these asymmetric folds, suggesting that it's a sinistral shear on this fault. And again, some more examples when these lovely wave washed sort of gullies, you get these sort of these beautiful mylonites in that shear zone. Again, all demonstrating, I think, a sense of shear that's sort of sinistral, so the top bit has gone to the left, basically. And in thin section, you see a lot of these sort of shear bands through here, going this way, like this. And then you see these micas lined up like this. And these are called C bands and S bands. There's a CS shears. And again, it is a sinistral sense of shear in this. So picked up by the micas, but these shear bands coming through here. So yeah, classic sort of myelonitic textures, and you can use it quite nicely to get a sense of shear from it. So that's the CS shear band fabric. This is the metabasite in here, and then I wondered what on earth was this thing here. What was this doing? And I looked at it. This is an intrusion, yeah, and this is a lamprifier. So this is intruded in the shear zone. So this is a lamprifier. These apennite type things are dated at 420, 425 Silurian sort of age, and they follow. Often accompanying and following the trend of strike slip faults related to the Great Glen system. And this Kilkieran shear zone seems to follow the same trend as the Great Glen and other faults in the area, and is intruded with a lot of lamprifiers. There are lamprifiers all over this shear zone area, trending along the fault planes. Also, when you look at the grit, near the contact, the class, most of the class in the grit aren't distorted, but they're near the shear zone. We do get this sort of elongation again, which is an elongation which is northwest, northeast, southwest, which is following the trend of the shear zone. So just a sort of bit more evidence about the sense of movement on it. Further down, just beyond those tidal pools, there's a tertiary dolerite dike, which is here. That picture's taken here of it here. Then it goes into a fault gully, into the fault zone here, and comes out the other side displaced. So you could argue that there's a displacement even of a tertiary dike in a sinistral sense, i.e. it's gone that way. Even a small amount of movement, only a few meters, 20 meters or so, maybe that's tertiary movement. But it seems to be that a lot of the sense of movement of this fault is this sinistral strike slip. So I wanted to just take a glass of water and just take a little look at some of the previous work that's been done on this. If you compare the number of papers that have been written on the Rhinns Complex, the number of papers written on the Lewisian, it's virtually, it doesn't compare. There's one or two major papers on the Rhinns, one in particular, and that's pretty much it. compared with the Lewisian, which has, I guess, got hundreds of papers written on it. Let's take you back to 1907. This is the original survey map from 1907. Wilkinson, supervised by Peach and C.T. Clough and all these good people, but they basically mapped what they saw, which was the pink gneiss and conveniently coloured pink, and the green Metagabbro conveniently coloured green. And there's Kilkieran Bay, and this is the contact they were looking at in here. Yeah, but they looked at it here and they saw conglomerates over here. They put these dotted conglomerate symbols here, which they didn't see here. And they called this the basal conglomerate, and they drew a cross section across here, and they had these little sort of folded in, they love the word puckered. They called it a puckered sort of folded sort of thing, with these sort of conglomerate sort of nestling in folded little pockets. Yeah, here, and then the shear zone, I can't believe, but we saw it dipping this way, but they drew it this way, but I don't understand that. Anyway, nevertheless, that's what they drew. And this is they called this Torridonian, and they called this Lewisian. And that was, until 1981, that was certainly the belief, because there was no dating done until the 80s. Sandy Stewart and his pals got together, did a bit of work on this contact, and here's Kilkieran Bay, and here's the fault zone, and they thought they could trace it in this sort of curved fashion, trending all the way across the coast, all the way across to Bruichladdich. Right, they had this curved fault zone with a sort of gravelly, with the grits and things sort of on there, and a little patch over here and a big patch up here. The survey people, the Wilkinson and Co, had mapped this up here as well, and I'm going to show you some pictures of this. I don't think this is a meta sandstone, and in fact, Rod Muir later on mapped this as a shear pegmatite syenite. But this has been variously correlated with the Bowmore sandstone and this grit. So it's we'll come on to look at that in a minute. But there's some. How does this work? Here I'm seeing sinistral movement, yeah, and Lamprifier intrusions, and and we got dipping this way with the folds. So we've seen that bit. This was their cross section with the Lewisian and these sort of things onlapping onto the Lewisian in some sort of strange manner, and a fault somehow doing this. So quite understand what Sandy was trying to do with his fault plane, but he had something like this with a sort of folded. But the paper he wrote presents no evidence of actual folding. It just there are some dips going this way. There's some dips going this way. So you could map a fold, but there's no actual evidence of folding per se and we'll look at that in a minute. He thought there was a flat-lying shear folding with a mineral lineation and a second deformation with the shear zone folded. So a deformation related to the generation of the shear zone, which was then folded by a second deformation. That was the sort of the story that was evolving at the time. Bill Fitches and Alec Maltman, the Aberystwyth mob in the mid-80s, had a good look at this structure of Islay and sort of came up with this model. Here's the Grignard fault here. So this is the main Islay anticline system, which they had as a big fan sort of thing overlying the Loch Skerrill's thrust in here, big sort of anticlinorial fan type arrangement underneath over the Loch Skerrill's thrust, and then a sort of different deformation going on with sheath folding and cleavages and grain elongation, except the grain elongation is along, it goes parallel with the fault trend with the shear zone. But this is how they drew it, with these sort of slices of basement in the Colonsay Group and these sheath folds, and the unconformity basically acting as a shear surface because of the rheological contrast between these what would have been pretty thick, maybe 15 kilometers of wet sediment sitting above something, and then this stuff that would have been hard, dry basement. So you've got a huge contrast, and no wonder shear would be focused onto this boundary. So you could expect deformation at this boundary in any way. Rod Muir was the guy, and again, following on from the main Aberystwyth team, he did this slide's moved. That green's, oh God, that green should be over here. Sorry, I'm not going to change the slide now. All these green lumps were my colouring of the of the Colonsay Group. Sorry about that. I've just realised it's shifted. Rod Muir mapped this and again confirmed the sort of northwest, south, northeast, southwest trend in the foliation of the Rhinns Complex. Mapped the some of the folds in the Colonsay Group around here, and identified that he said that this stuff at the top here was definitely was igneous, not sedimentary, but there was a patch of it, sedimentary rocks here, and a load of conglomerates down here. So these are a load of conglomerates picked up down south of Port Charlotte in a place called Octafad. There's a big farm down here, and he looked a lot at that. This is a cross section across there, showing the sort of Colonsay Group on that side with its sort of steep northwest dipping fault zone. This section's moved as it should be over here. Sorry about that. But then on this side, this stuff on the Octafad area dipping in that way. So, but basically the whole thing dips steeply. It doesn't turn over flat. The foliation doesn't turn flat and like an anticline. It is, if it's any sort of anticline, it have to be completely isoclinal because the foliation is just very steeply dipping to the northwest, mainly on this side, and mainly nipping to the southeast on this side. And a lot of the boundaries between these major gabbroic intrusions are sheared as well. And this is the sheared philononites down in Port Haven. So he said that the foliation in the Rhinns was mostly vertical, but a high angle. I've just said all that with this sort of Caledonian trend to the strike of the foliation. And the Kilkieran shear zone was mapped as a fold. You can see there's a sort of tucked in little fold in here, around here, an anticline and a syncline, a tight anticline and syncline up in the Dunmaida area. They did a bit more work on this conglomerates down at Octafad, and this is what we're going to have a good look at in a few minutes' time. We're going to head down that way, and they did a bit of work looking at this so-called anticline-syncline pair at Dunmaida and the conglomerates. So the bit of work was done on that by these guys. The Dublin mob got involved in later on, 20 years later. So this is Claire McAteer, Stephen Daly, and Martin from Stockholm, and they took a lot of samples to do some zircon provenance type work on the Colonsay Group, and I'll refer to this several times in the next wee while. In terms of the southern part of the section, which we're going to be not this northern bit, and the southern bit, the key samples, and we'll come back to them several times, are 4 samples they took at Kilkieran, and they did whole rock geochem on those 4, that cluster of in the sandstones and the metasiltstones in the Kilkieran area we've just been looking at. And then this Octafad area where there's some conglomerates, which you'll see in a minute, and they took 4 of the clasts and a siltstone matrix sample and did some lead zircon stuff and some whole rock chemistry on the rocks down here, and we'll refer to that, as I say, as we go on. What they did, this upper section and into Colonsay, it did confirm to them that the Colonsay Group has got to be younger than 942. So at last we have something to go on. 942 could be any age. You could still correlate with Torridonian, with Moyne, because it's got to be younger than that, yeah. But that still gives you quite a lot to play with, yeah, in terms of ages for it. They thought, based on the sort of detrital zircon profiling, that the best correlation was with the Grampian Group further northeast. But the problem with the Grampian Group further northeast, it only has one major phase of deformation. And yet you've seen some of the work that has previously been done here suggesting that there's 2 deformations. So if there are 2 deformations, it probably isn't the Grampian Group, and could well be a Moyne or a Badenoch Group type correlation going to. So the correlation, the zircon stuff. I think I'm going to show you some of the plots in a second. But this correlation to the Grampian Group would be strengthened if there was only one phase. If you could argue that there was only one phase of deformation, not 2. Yeah, I'm not going to go into the detail of this because it'll take forever, but these are the plots that Claire and co put up, showing the sort of the probability distributions of the detrital zircons in the Torridonian, the Moyne, and the Dalradian, and then some details of the Grampian Group, which they were correlating it with, suggesting that the Colonsay Group and the Bowmore group which is arguably younger than the Colonsay Group, do have correlatable successions in Coriaric and Strathtummel, with these various somatic and pebbly beds in here, and the general succession in these fault-bounded basins again is deltaic to turbidite to fluviatile, which is what we see in the Colonsay Group. So there's a lithological and a stratigraphic and a zircon sort of similarity with that, and it makes kind of sense. But there's this enigma about, well, but if the Colonsay Group's got a deformation in it, which could be Neudatian type, Rhinlandian Neudatian deformation, then it could well be that you're actually looking at correlating it with things like the Glenfinnan Group and the Morar Group. So, you know, the jury's out on this, but the preferred, if you just weren't concerned about deformation histories, you were just looking at straight at zircon correlations, you would plump for a correlation with the earliest Dalradian and the Grampian Group. So let's just summarize what we've seen in the Rhinns Complex. This is Rod Muir's work that I mentioned. So we've got intrusion of syenite protolith, amphibolite facies to an orthogneiss, intrusion of gabbros dolerites, ultrabasics and pegmatites, some sort of metamorphism that changes the gabbros to these metagabbros, then a shearing event which Rod and co thought was post-cover, i.e. was Grampian, and then which was then, this is the early event, then was followed almost at the same time by the sort of main deformation of the Grampian group, the Grampian orogeny, sorry, green schist facies. So the dating 1.8 for the intrusions, 1.7 for the late Vaxfordian metamorphism of the whole lot, a shearing event, which if you believe it's post-cover would be at 470, yeah? So is that shearing, that all that shearing we're seeing in the Rhinns Complex, is it really 470? And if it isn't, where does it relate to? So in 1995, this is just basically just explaining that in a bit more detail, but they thought the early deformation, they concluded, following all the other people's work, was that there was flat-lying high-strain shear with basement cover interslicing. So there's lots of sort of things going on at the basement cover interface. And then this whole thing was folded, yeah? And folding of the contact. So the question really is, where does this fit? Is it the same as this? Is it related to this? And what age is this? And how does it relate to this? So that's the sort of some of the questions we're trying to answer in the next wee while. So this here's the current BGS map glued together. They've used a lot of that previous work and joined it all together. And there's the Kilkeran shear zone shown as a fold. This is Rod Muir's type fold. A little bit of conglomerate that they found here, not the same amount of conglomerate that Wilkinson and co found way back in the dim and distant past. It sort of goes through here, seems to change as it goes onto the other sheet, seems to be faulted out here and then comes back here, but it's actually within the Colonsay Group here, because it's Colonsay Group against Colonsay Group. And then here, they've got some rocks here, my house is just about built on, and they're not cyanites, they're metasandstone, so there's something wrong with the geological map here. And so since this little shear, this part of a so-called shear zone, which is the shear zone they've labeled from here, coming right round here, seems to underlie my house, I was quite interested to know what it was doing and how it could be. So this is what spurred me into sort of thinking about, and was this thing folded? I also thought this is a basement high. This is the typical basement high with the sort of onlapping conglomerate. If there are conglomerates, these are sort of basic conglomerates onlapping on the edges of the flanks of this high, and then the whole thing's overstepped, just like you'd see in an extensional setting in the North Sea. And I've worked on many basement ridge, like the Clare Field and the Buchan Field, and these basement highs are fairly typical in extensional regimes. And I was wondering whether this is what we were seeing here. So I had a good look. I wanted to see whether that could be that hypothesis could be evidence I could have to support any hypothesis like that. There's a typical cross section. This is the dipping to the north southeast on this side, and the dipping and the younging on that side. This is very poorly exposed, very conjectural sort of arrangement here. But this looks like you've got if it's an unconformity, it's doing this. What's that about? And here, so this contact, though it's a thick black line folded here, is that what it is here? And then there's this inlier here. Then there's all these little scruffy bits of meta sediments plastered on the edge of the thing down here. What's their contact like? What is the contact down here? So, and there's the lumber here, and there's there's no exposure at all, so I've no idea what that is. So we're going to jump around. We're going to go to Dunmaida, look at this folded area. We're going to go to back to Bruichladdich to have a look at some of the shearing. We're going to go to Port Charlotte, look at this inlier, and we're going to Octafad and Ellister down on the south coast there. And I've no idea what the time is. Yeah, okay, well, we're just going to run through all these places. Dunmaida, here's my map. There's the shear zone at Kilkieran. Seems to come up. It seems to be offset by a few of these later Mesozoic tertiary faults. It seems to be broken. I think it goes on and on and on. I'm going to show you some pictures of on the thing. I don't think it folds around at all. There are some conglomerates. There's some conglomerates here, and there's a little patch of conglomerates here at Dunmaida itself, but it's very small. And I think the whole thing is just a whole sort of chopped up, faulted tip of a block that's dipping down and plunging down to the northeast. And you get these sort of fault slivers. So I don't think I see any evidence here of any folding. We'll just have a look at some of the evidence here. This is the Google Earth map. There's Kilkieran, and you can see this feature running right across through here, like this. And you can map this. You can walk and see the different rocks on each side, and it gets a bit more dodgy as you go up here. Just have a look at this area in a bit more detail. Yeah, there's the fault zone here. This is what was mapped as the termination of the nose of the folded thing here. This is the sort of exposure you're looking at. It's rubbish. It's difficult country too. It's hard to get around. The rocks are exposed in little tiny patches. It's quite difficult to make a sensible map anyway. But anyway, you can do what you can up here. There's a typical example of where the Kilkieran shear zone is. That's nice on that side, and that's meta sandstone steeply dipping with a lot of quartz veining in it. So this is what you find on the ground. So you can map it, but you can't really get at it like in the same way that you can in the seaside. Yeah, you can find some nice sheared rocks nearby. Again, here's a good example of some bedded sort of siltstone, sandstone stuff, mudstone, siltstone stuff with a sinistral sense of shear. And when we get to Dunmaida, we don't find anything like the expanse of conglomerates that Wilkinson mapped. We find it just little tiny patches, and they're very difficult to see. This rock is covered in lichen. When you look at it in detail, you say, oh, there's a clast. There's a clast. Look, little clasts. Yeah, little quartzite ones, that's a quartzite, and there's some granitic type clasts in it. So you do get them. Here's one and it's very deformed. You can see here there's a sort of monolithic texture to this thing. And you could argue, and Alistair tried to argue with me that these were actually large algons of a gneiss, and it wasn't really a conglomerate at all. But this is different lithology here. This is a sort of perhaps a bit of the metabasite or something here. So but it's a very sort of sheared, sort of foliated sort of conglomerate that you find up at Dunmaida. And as I say, it's difficult to get your eye into these things. These are horrible, scruffy outcrops in a lot of vegetation. And you do find sort of evidence of class. There's an epidote, some sort of epidocite here. There's a lot of this fracturing cleavage here is a sort of this volume change. It's very typical of epidote. So you get epidote, lumps of epidote. But it's overlain by these beautifully cross-bedded epidotic sandstones. A lot of the epidote in this sandstone, and it's maybe derived from some of these Rhinns Complex rocks that it's underlying, but this seems to overstep. And it's not actually that deformed in places. It's just steeply dipping, but there's beautiful cross-bedding in these sandstones above it. And also, there's a lot of folding going on, some weird folding going on. Yeah, this looks, to me, this doesn't look like a tectonic fold. This looks like a soft sediment slump fold to me that may be enhanced by some tectonics. You've got some quartz veining going into the sort of anticlinal noses of things, but there's a lot of these folded structures like this that could be slump folds in this sequence. And here's some more here. And you can see this layer seems to have a lot of folding in it, and this layer above doesn't have any. And you could argue that those of you who saw some of the Ian Allsop's talk on seismites might suggest that this is what you're getting here. I haven't done enough work to try and really prove that, but the fact that you get beds that are very distorted and slumped, and then beds above it that aren't, suggests that there is some soft sediment deformation going on here. which makes structural geology interesting, because if you've got a pre-existing fold structure before you even started any deformation, then you deform it once or twice, no wonder it's a mess, yeah? So let's head over to Bruichladdich, and where we started, we were down by the distillery looking at these sort of nice undeformed, pretty much undeformed pegmatite cyanites and metagabros down in here. But up in the north, we find these this bed of extensive sort of outcrop of this grey laminated stuff and some what looks like a sort of quartzite. This is the laminated stuff, grey laminated, looks like a sort of laminated siltstone that you see on the other side, but it's quite a lot of folding in it. You can see here, there's a lot of fold. This is, if you can argue, the other one's a sinistral, this is dextral. This is going the other way, this is going to the right, pushing these asymmetric folds the other way. And a lot of these noses are filled with quartz and calcite, and these little anticlinal noses here. And there's a lot of segregation of micas and oxide minerals in these rocks too. Further north, this is the bit that was mapped by the original survey as Bowmore sandstone, and by the Stewart and Hackman as one of the Colonsay Group sandstones, and by Rod Muir as a cyanite. Now, I first looked at it, I thought, when I looked at, I got a thin section of it, there's a lot of quartz in it, and I think it's a sheared pegmatite. But it looks sedimentary. You look at that and you think, oh, that's a gravel, that's a grit. You can see here banding in it. Then you see other bits, you think, well, there's something like that, it could be sedimentary, but then you look at these things and you think, these are algans? Is this a gneiss? Is this a metamorphose? There's something strange going on in these rocks. And you see this sort of features as well, where you get this sort of foliated metabasite, and then the sort of cyanite type things here. And you could argue that is this quartzite and meta mudstones? What's going on here? What's happening? And you look at it in detail and you think, this is metamorphic. This is a gneiss. Yeah, these foliations are segregated. This is actually not a meta sandstone at all. This is all meta igneous, and it's just incredibly sheared. And there's an example down here where you get extensive exposure of all this pink stuff that looks like the Bowmore sandstone, looks like it's intruded by this stuff here, and it's all sheared. So it's a good example of the Rhinns complex being complex, and it's, you know, sometimes when you start geology, you think, oh, I can tell the difference between an igneous rock and a sedimentary rock and a metamorphic rock. Not here, you can't. You're really struggling. So let's continue with the struggle and go down to Port Charlotte, where lots of people, well, several researchers have struggled again trying to define the base of the cover sequence in this little what's so-called Port Charlotte inlier of rocks that sort of squeeze along the coast here. We know we've got gneisses, pink gneisses here, pink gneisses up on the hill behind Octomore Farm, pink gneisses down at the base down here, and an outcrop of pink gneiss on the beach at Port Charlotte. So there's just this sliver of sort of weird looking rocks that go along the coast here, and there's a big tertiary dike going through where the lighthouse is. It's the green splodge. We just should have put it in the legend, but I didn't. This is the alleged contact in the north that Claire McAteer marked and thought this was nice and this was metasediments. But as I showed you before, these are almost certainly sheared, incredibly sheared gneisses and interbedded foliated metafelsic and mafic gneiss sheared with algans in it. The contact, this is a metabasite here, the contact is actually obscured by this little dike here, but this is the metasediment senso stricto here, we believe, which extend southwards from here to actually past the lighthouse and round the corner into the village. This looks like it's conglomeratic from a distance. When you look at that, it's all lichen. Yeah, it's fooling geologists. It's this sort of stuff here. You look, oh, there's some conglomerates, there's white lumps and clasts, and you get there, it's just nothing. It's just horrible biology. But these rocks have got the same sort of this foliated grey. Well, if it's foliated, it's metamorphic. If it's not particularly metamorphic, it's bedding. Yeah, and that's what it looks like. But when you look at it in thin section, it's quite tricky to actually ascertain, because you could talk yourself into this being a gneiss, but otherwise, so you're struggling between, is it a laminated metasiltstone, or is it some sort of low grade sheared metabasite of some description. It's got these folds again. It's quite, there's lots of areas where it's quite contorted and quite folded, like we saw earlier up at Port Charlotte, Brookleddy. There's a pink area of pink felsic gneiss on the beach here, and then there's this sort of bedded metasedimentary stuff here. Those other things I was just showing you were just on the other side of the bay here. And here's the contact zone between these felsic gneisses and this sort of crudely sort of wavy bedded sort of stuff that looks like metasiltstones and stuff. And it's slightly different. This is striking this way, and this is striking this way. So we've got a different angle of the sort of geological lineation here. And when you go further south, the whole of this sequence south of the village is pretty much the last house in Port Charlotte. The whole sequence is this sort of, I almost call convolute, sort of wavy bedded sort of metasiltstones. Sort of gently sort of folded and convoluted. But in places it's quite folded. You can see these folds in here, quite folded. And these are some of these so-called early sheath folds that was mentioned in the literature about. So this is one of the areas where these early low angle inclined sort of low angle folds were described from. But they're weird. They look. You could argue that these are folds verging in two directions. Again, it looks to me like you could make a case for that being sedimentary and a slumping type feature, like we saw further up on the Dunmaida in the meta sandstones there. This just looks a weird sort of feature, and you also get this sort of thing going on, yeah. And then above it, it's sort of not so folded. So again, is this slumping? Are these seismites? Are they something weird and wonderful going on here? Possibly not tectonic, I don't know. There's a thin section on these little folds, sort of micas, biotites and chlorites, sort of. So you've got sort of maybe this is a lot of feldspar in here, some plagioclase as well in it. So it's a sort of trying to understand what's going on with the sort of the history of these little folds in this rock is quite interesting. There's also what I would think to be some metaigneous rock here. This looks like a metabasite which has been carbonated. This whole rock here is just full of great lumps of calcite, and as if it's been green schist metamorphosed in a hydrous environment with a lot of carbon dioxide and water, like you see on the south side of Islay. And you get this rock just looks like it's just got great holes in it because all the calcite's been taken away. And in thin section, it's just a mass of calcite and some messed up mafics and stuff, and bits of relic plagioclase and stuff. So again, a sort of funny sort of igneous rock in this succession. So, and then you get this sort of grey, sort of not quite so folded sort of stuff. And then this is the gneiss here. So you get this sort of funny contact between the two. It looks a bit like this. So you think, is some of this green stripy stuff, is it metabasite that's been foliated? Is this lamination a metamorphic foliation, or is it back to the bedding? What's going on here? This all looks deformed, and it looks like this is the pink gneiss and the green metabasite, but it's weird and it's fine grained and it just confuses you. Then there's great slivers of gneiss. This is a great chunk of gneiss with a sort of fault and a fault here, because you get these laminated, contorted beds going each side of it with this great chunk of gneiss in the middle. So, yeah, just the story continues. You go to Octofad. I mentioned Octofad because this is where Claire McAteer and co. and Rod Muir in the 90s had found conglomerates, and these little orange blobs here are conglomerate. This is the one they mapped and they saw, and but I found another huge exposure here which they hadn't mentioned. They just concentrated on this one here, and further to the north, the north part of this exposure, before we get to the conglomerates, you see this is metabase. This is cyanite gneiss here. This is this homogeneous sort of it's a sort of poorly foliated, fine-grained rock, and then there's some sort of feature here, and then this is the contorted, convolutedly bedded stuff with some of the sheath folding in it here, and there's probably some sort of fault here and a fault here. So you've got three rock types here, which I've shown on the map, which is the sort of the undisputable felsic gneisses of the Rhinns Complex. Some of these what I would still argue is metasediments with the folds and the sheath folds in them. And this stuff in the middle, which has got a sort of poorly foliated, and it's light green, full of epidote and chlorite, and just looks horrible. Here's some of these folds further down. This looks more like a tectonic fold. So does this one. Looks like this little bed of quartzite has come squeezed up this way. It looks like this is a sort of sheath fold of some description, but you can see how that's streaked out that little syncline there into this, and then the anticline of this little sand bed has just done that. It's quite nice. This is the conglomerate outcrop that the previous workers had found. This is the green horrible stuff here. A lot of it here. Green horrible stuff here, and then you get here conglomerates, and at the top of it the folded stuff. And it looks like what's happening is that the conglomerates are the basal unit of this convolutely folded metasediments, and this green horrible stuff is probably unrelated to it, and it may be Rhinns Complex of some sort of lithology that hasn't been described before. Let's have a look at the conglomerates first. This is the bed here. These are the little, and it's quite stretched out, but it's been stretched out and it's been compressed, because you've got this sort of what looks like almost a boudinage bed that's then been folded. Yeah. So I'd be interested in people's thoughts on that. This is some of the grain, the clasts in it. Some are flattened and squashed, and other ones are not particularly flattened at all. So it's but Claire McAteer and Stephen and Martin Whitehouse and co did some work on these and took 4 of these clasts and a sample of the matrix, and they dated them, and they said that 2 of the clasts were Rhinns, i.e. 1800, and 2 were younger, 1400. So that sort of only 4 samples, but basically it showed that these rocks weren't just Rhinns, local Rhinns rocks. There were some rocks coming in from other places. The sandy matrix had ages that sort of fitted that as well. The age, there were 17 zircon ages that were concordant dating. So some of the zircons were Rhinns at 1760 odd, and some were at this 1400 thing here. Yeah. But they also made an interesting observation that the whole rock chemistry of this sample, only a single sample albeit, was similar to the Eilian Leith grit at Kilkieran that we saw. So their view was that it was that it was related to it and could be sitting stratigraphically below the grit on the west coast. So that's an important sort of bit of stratigraphy. And it's also important that the date that we've got these younger dates in the matrix. This isn't a Rhinns rock. This isn't coeval with the Rhinns. This is younger than the Rhinns. It has Rhinns derived class in it. Yeah. But it's still quite old. I mean, the youngest rim date in the matrix of a zircon matrix is 1380. Yeah. In detail, if you look at this conglomerate unit, this is the bed that has the conglomerate and these sort of folded little quartzite layers, it gets pretty weird here. I'm not sure whether this is a great big lump and whether this is a lump, and these are faults here. And this is the green horrible stuff that I think might be Rhinns Complex fine-grained lithology, and I think these are faults. And I think this is an example of a fault contact with the basement that may have been extensional to start with, and I'd be a fault scarp. Then it's been inverted and reversed and turned into a high angle thrust. But that's just a hypothesis. You can't prove that from this particular outcrop, but this could be a large clast of this green stuff here. And there could be several faults in here like this. Certainly these beds stop here. And this is the conglomeratic unit here. And this isn't. This is Alistair, who I believe has to leave parental duties. But there's the conglomerate and that folded sort of boudinage bed, and the faults up here to the horrible green stuff above me in the cliff here. And then this is the pebbly beds here. Some pebbles in it. Alistair's pointing at a few clasts here. And this is the syenitic gneiss underneath it. And there's this sort of meter or so of sort of sheared rock here. So we've got and this is sub-horizontal. This is actually dipping about 10 degrees to the northeast, this phyllononic, well, this sheared layer. but there's a fault contact at this end of it. So it's a weird sort of outcrop, sort of sandwich between a fault this way and a basal shear plane, sub-horizontal shear plane. And it's just a little sort of wedge of rock. So that's the sort of sheared rock in there. And here's a sample of it, a lot of muscovite and biotite. Again, these are CS shears. There's a sort of shear plane here going through here, then all these micas that are sort of high angle to it here. Whoops, I meant to just, yeah. So this is, again, this is demonstrating, and again, that's an orientated sample, and it's demonstrating a sinistral sense of shear, i.e. top to the northwest is where is the direction that's pointing me at. It's gone that way, and that sample is orientated. So it's actually what I was looking. Oh, you need to go back. Sorry, let's go back to. I was kind of, what I'm trying to do. What I was attempting to do was find some lineations on this to try and show me anything, but it's very, very fine grained. It's very difficult to see anything on the surface. There's no sort of fold axis lineation, mineral lineation. It's just sort of a cruddy brown, dark grey rock, and it's only in the thin section that you can actually start to see some sense of shear indicators. Further around the corner, going south, this is the outcrop that wasn't mapped by the other guys, but this is the gneiss here, and this is these are pebbles. You can see here, there's a contact here, and it's not that sheared. Yeah, here there's not the same sort of. You just see pebbles sitting on the gneiss. This looks like a proper unconformity, and there's obviously some shearing going on because some of these clasts are quite big and sort of strung out. And here's the unconformity here. So this is the bedded conglomerates here, and they trend upwards into these sort of thicker beds here. And this is the gneiss here. So you've got a lovely unconformity just sitting there. Over this side of the gully, it's all gneiss. You can see the pink stuff over there. Yeah, but just got this little patch of conglomerate here. That shear zone, there's a bit of shearing at the bottom, and again, more of these CS shears with a sinistral up to top to the northwest sort of sense of movement on it, like this. And further around, you get some fault, seem to get fault. This is gneiss here, and then you get gneiss here and a sort of sandwiched chunk of breccia, or big angular conglomerate breccia type stuff sandwiched in it. And coming round the corner, this is the unconformity surface here. The unconformity surface is visible in this sort of like a cutting through one of these geos, but it sort of goes like here. This is all conglomerate up. All the upper section here has got conglomerate in it here, and it comes through here and up here, and up here, and then in this chunk here, and then up there. Like there's some faults I've just quickly sketched onto it here. That's the conglomeratic unit looking a bit like that. And this is where I sort of tend to, the sort of interpretation that it was an extensional fault system that these were fault scarp type deposits against an active extensional fault that has been reversed and squished with a north. So it's been pushed that way. That's what the sense of shear on the basal plane shows me. It's gone that way, and it's squished it up. So it's an extensional system that's been reversed. That's my interpretation. I'm open to suggestions. Just going to quickly, before I finish, just go down to the last outcrops down at the bottom end of the island. This has all been mapped as metasediments, but when I get down there, this blue stuff is almost certainly schistose metaigneous rocks, little patches of conglomerate. Oh, this one's, no, it's not upside down. Sorry, yes, that's the sea here. And there's metabase. There's the Rhinns Complex down here. There's some sort of big quartz boudin sort of vein thing in here, and there's pebbly conglomerates there. But all these so-called metasediments that have been mapped there look like this. This is pink gneiss here, and this is this sort of spiky schistose sort of rock here. And here's the gabbros here, and then there's this schistose, what I call the spiky schist sort of rock here. And it's in contact with, it's got sort of albite porphyroclasts in it, and it's got, there's the pink gneiss next to it, and it looks like it's related to it. So this is trying to tell me something here, that it's related. And it's got, if you look at, there's the big feldspars in it, and there's these weird sort of things with titanites with great rutile needles in them. This particular picture doesn't do it justice, but they're beautiful. And some of the rocks further north have got the same sort of weird mineralogy in it. John Faithful said this looked volcaniclastic. So, and it's got, all this is biotite. It's got biotite, it's got allanite, and these big feldspars in it. But it's been mapped as metasediment. This has been mapped, and it was mentioned in Claire McAteer's work as a channel. Not convinced. I think this is all meta-igneous or meta-volcaniclastic, and it may not be. It may be Rhinns, and if it's Rhinns, meta-volcaniclastics, or fine-grained igneous, is it supercrustal? And if we got supercrustal Rhinns, not just deep stuff. So that's an interesting thing to look at and think about. There are some conglomerates here. There's the schisty, nasty schisty stuff, the meta-igneous, meta-volcaniclastic-y stuff. There's a conglomerate wedge, and there's some folded metasediments with a conglomerate sort of sliver caught in it. Again, with this interpretation that I think this was maybe an extensional fault with the conglomerates and the metasediments, then it's all been squished up, and these asymmetric folds sort of give you that sense of movement up to the northwest. And there's some beautiful conglomerates. There's actually some of the best conglomerates. It's only a small little patch, but there's some actually beautiful, great big class, undeformed class in this thing here. You can see these things big as a hammer. Yeah. So nice little conglomerates there. So if there is a conglomerate and it's in contact with the basement, could be Dalradian. Is this the base of the Dalradian? Now, is this actually the base of the Dalradian? And if it was, can we date it? So geology, to me, is like a jigsaw puzzle, except you don't have the boxes, you don't have all the pieces, you don't know what the pieces look like, and you've got bits missing. The best you can do is piece together a few bits and pieces and hope for the best. So it's quite a nice analogy and this is a good place to use that analogy, because this is what it's like here, as you've just seen. It's a complete jumble of stuff, but you can piece together little bits to try and make some sort of story. When I first looked at this stuff, I thought, this is the extensional basin. Why can't the Rhinns be one of these schematic sort of faults in it? You get in extensional basins with an antithetic, and you get these little basement horsts. Yeah, why not? Why can't the Rhinns block be something like this? Yeah, and this is the sort of typical extensional diagram that Roger drew, that showing the development of the basin, and maybe the Colonsay and Bowmore group sat in first into some sort of rifted feature as this Rodinia started to break up. So this is actually the Rhinns. The unconformity is the Rodinia breakup unconformity, possibly. I like to think of the Bowmore and Colonsay groups as something like the British Perma-Trias, which is a sort of precursor to the main Atlantic rifting. And maybe some of the faulting is unrelated to it, but nevertheless, it's a precursor to the rifting that then took the true Atlantic rifting that started in the Jurassic. So it could be something like the Perma-Triassic analogy, except it's marine, obviously not non-marine. Then it's followed by the main Dalradian sequence and the Southern Highland stuff and the volcanics at 600. So some sort of picture like that is what I was envisaging. This is this Rhinns hall. I just drew a little cartoon to show what this might have looked like, with sort of basal conglomerates sort of hanging about on it, and then compression. So this is the inversion. So you get this horst block, this extensional horst that's then squeezed and squashed, and maybe the Kilkieran shear zone is the antithetic fault to the horst system. So it's just a possibility. Other interpretations are possible. But here's an example. This is a cross section across a current extensional basin, i.e. the west of Shetland. This is the Clarefield. I sat on an oil rig here years ago and was astonished how much oil there is in it. But what would happen, I thought, if you actually then, at some stage, this becomes an orogenic zone and this gets compressed? What would happen to this feature here? Yeah, what would happen to these fault block features? What would they look like in a compressional orogenic event? So you don't always get extensional faults all going the same way. You see, you've got an extensional basin with the Atlantic out that way, but some are going this way and some are going this way, and you get all these different, and you get these basement high features going all the way out. So it's a complicated topography, a complicated fault pattern, and then you go and complicate it even more by inverting it, and possibly inverting it at a different angle to the direction of the extension, so that you really get things messed up. I'll run through these inclusions very quickly because we're running out of time. So I think the Kilkieran zone has a late Caledonian sinistral strike slip component. It may have overprinted an earlier history of extension and compression, but all we see at the moment is it's a Caledonian sinistral strike slip feature. We get small amount of basal conglomerate in Dunmida, and I don't think it's folded in there. I think there's a lot of faulting, and it's a complicated sort of fault slices. The fact that we see a lot of complicated fault slicing on the coast where we can see better exposure suggests that's the model rather than a folded contact. You get it. It's just a lot of faults chunking the place up. So these are the fault scarp settings for the Colonsay Group on the east coast, which I think were inverted. So there may be some meta-igneous and metavolcaniclastics, some originally mapped as meta-sediments. These could be supercrustals, and I think they need to do some more work. And I have collected some more samples. I'm hoping to get some zircon work done on that when life turns to normal again. I think some of this shearing in the Rhinns is related to the Laxfordian. It certainly doesn't seem to be pervasive right through the whole sequence. And I don't think it's post-cover. So I think this shearing and all those white talc rocks and all that philononite stuff is related to this late Laxfordian stuff. Yeah, and I don't think it's even amphibolite fascists. I think a lot of it is at green. Most of the deformation is shearing, and I think the actual metamorphic grade is probably green schist. It says amphibolite, but there's no evidence that it's amphibolite. I think it's green schist. There is bedding parallel foliation and sheath folding in these basal conglomerate, basal metasediments, which I think is consistent with deformation close to the contact related to that rheological difference. And I think it's all part of the Grampian stuff, along with some soft sediment deformation that's confusing the picture. Yeah. If there is only one deformation cycle, you've got progressive deformation through these fault propagation folds. I think that you don't need to have two deformations in the Colonsay Group. Certainly to the north of Kilkieran, there's no evidence, there's any suggestion that there's two phases of deformation. It's just right close to the basement contact, which is what I'm talking about here. So I believe the Dalradian Grampian group correlation with the Colonsay Group, and I'm prepared to believe that. Which case it is the best place to see the base of the Dalradian, because it's a good place. I know you can see it up in the Grampian area as well, but there's some good places to see it. Yeah. And I think it's part of the early break of Rodinia rather than the Colonsay Group being a post-Grenville fallen basin. But again, the jury's out, other interpretations are possible. Whew. Sorry, I went on a wee bit, but there we are. Time for a dram. If you want to use chat to ask questions, please do. I'm just going to pause for a second and take I think I'll have a wee drink of water and a whiskey.
Well, thanks very much, David. I think you've got us all wanting to catch the next ferry to Islay.
As I do say, the geology of Islay is fascinating. That's just one little corner, and that's one little problem. You know, we've got. I've got to go out on Saturday, and do a whole lot of mapping in the north for Tony Spencer, and he's looking for cap carbonates below the Bunnahabhain dolomite. So there's huge stories to be told here. You know?
Yeah, it's amazing. We started the talk with a nice little story of red rocks and green rocks, and soon got rather more complicated.
Well, the thing is, yes, I mean, you can tell the basic story. There's green rocks and red rocks, and most people are happy with that. And you then some people are quite interested in the sort of Laxfordian correlation, that it's related to it isn't the Lewisian, yet it is in some respects, because some people quite like that story, and the fact that the rocks are the same as the rocks we see in Sweden, Norway, Rockall, Labrador, Greenland. You know, that mobile belt is an interesting story on its own. But this contact is interesting. I was fascinated by the contact, and I wanted to sort of explore it. So the exposure in the center, with the critical area in the center at Dumida, is pretty rubbish, as you saw, and any interpretation is possible. You could, if you wanted to, create some sort of weird thin-skinned isoclinal fold structure because of that. I'm not convinced. You've got all this. You've got 20 odd kilometers of soft sediment overlying metamorphic basement, which must go on for 20 kilometers into down to the Moho. So I mean, I don't know how you thin skin that unless you've got some sort of thin thrust slices like at Glenelg. So there's, you know, you can interpret it that way, but I'm not convinced. You need more evidence than you've got at the moment, I think, to try and interpret some sort of thin-skinned folding of the gneiss. What makes more sense to me is it's just chopped up by faults.
Yeah. Any questions? Get some people asking some questions. Some people must have.
Don't be shy. I'm here. I'm drinking my whiskey. Don't be shy if you've got. Yeah, people are saying thanks very much, and you must get a visit. Yeah, do get in contact with me if you want to visit Islay, because I can be quite flexible. I'm happy to take people out. I'm not a GeoWalks. I'm not doing it as a business. I don't charge. I just love sharing Islays geology with people. So do, if you do think of coming on your own, do come. I mean, we're trying to run a Glasgow GeoSoc trip, which was postponed from last Easter. We're going to try and run that next year. Someone said I need a big excavator. Yes, I'd love to do it. I did a lot of geology in my youth in the Kalahari, and we used to just dig trenches. You know, that's what we did. We had an excavator and we just dug trenches. When you found what you were looking close to what you were looking for, you just dug a dirty great trench. Now, you do get that on the coast. These geos, and these which follow tertiary faults mainly, do give you those lovely cross sections, and they're clean, and that's where I've been getting the evidence from. Because in the centre part of Islay, it's roadies and deer and dwarf willow and scrub and deep bog and ticks, and it's bracken and it's clegs. It's you know, every geologist's nightmare. And you go there in the winter. I do a lot of my field work and pictures there are taken in November and February because you know, it's the vegetation's down and the bugs are away.
So it's amazing to see such good exposure of the shear zone. I mean, that's an amazing place to go and visit such a shear zone with such a lot of variety of different structures and textures and so on. I can't think, you know, of all the shear zones I've seen bits of, that's up there. So look at it.
Yes, I've taken, when the tide's low, you can get into that shear zone at Kilheran. You know, the pictures I've taken have been sort of, often when I take people there, the tide's not right. You've got to have a low tide and low swell, and it is facing out into the Atlantic. So getting the tide right on the day you've got people there with the right weather and the right swell conditions. But I've got into that zone several times. I've taken a group, a sort of GeoWalks type group into it as well. That was quite exciting. It's a very atmospheric place to go, you know? And yeah, you can see some beautiful geology in it. Yes, Bill's just said he's been to Islay several times with me. Bill's been, and he says there's always something new to see. You know, I mean, the beauty of doing these virtual trips is I can take you down to those conglomerates from the comfy of your armchair with your whiskey in your hand. It's not easy getting down. I was down there yesterday taking some last minute pictures, and yeah, it's a steep descent down to the cliff, and get to that geo where the faults are visible. It's coast-steering. You almost need a rope to get into those areas. So it's I've been risking life and limb to get these pictures for you.
Anyone want to ask anything?
Anybody else got any questions? I mean, feel free. If you want to just take your mic off and just speak, that's fine. You know, I just didn't want it to be a rabble at the beginning, but you know. Okay, well, if there's...
We've all had our minds blown, I think.
Yes, there's a lot of information there, because when there's so many facets to that story, and that's what's... People ask me sometimes, what are you trying to tell us? What is the key message here? And it's quite varied, because you are telling quite a wide story that's...
well, and also it's not all been worked out. Part of the reason you're telling us this is because there's still a lot of work to do here to unravel it all.
There is. I want to do some more zircon work on these funny volcaniclastic, because that's a lovely story. If there's actually some supercrustals in the Rhinns, that's a good story. I mean, that whole mobile belt. If you go to Labrador and southern Greenland, there are extrusives in that age of rock. So it wouldn't be surprising to find it. It's just that they haven't been described here as such. So the problem is that getting students to do metamorphic petrology and stuff isn't sexy anymore, because it doesn't get funding. It's not related to carbon dioxide and global warming and stuff. And he says cynically, but so yes, it's you know, people say, well, why are you doing this? And I said, well, I'm just interested. I just want to know what's going on. You know? That's why we do geology. We want to understand the Earth. That's the basics of it.
So for anyone who wants to go back over what you've been talking about, you've recorded this talk, haven't you? Is it going to be online somewhere?
Yes, I've recorded the talk. It'll go on to the scottishgeology.com website where all the other ones I've done are. So I'll just I'll stick the recording on there, and you can look at it again, and certainly do come back to me with questions and any thoughts on it. I'm trying to put this together as a paper, but it's the same with any paper like this. You write something and you realize, well, I need a bit more work. Or wouldn't it be good if I did this, got some more zircon work done? Well, that takes time, and then the paper doesn't get written, and then you think, well, I need to conclude somewhere. You know, it's like any sort of thing like that. You've got to stop somewhere. But if you don't think the story's complete, you just don't want to finish it. You want to just leave it until you've got the next bit of that horrible jigsaw puzzle that I showed you in the box. You suddenly find another couple of pieces that belong to the, well, that maybe belongs to that bit. Oh, that goes there. Oh, yeah. So it's quite a testing sort of area to work, but it's the beauty of it. It's on my doorstep. I can just choose when I want to go and see it and just nip out the door, and I'm down at Brookladdy in 2 minutes, you know, on my bike. Okay, if there's no more questions,
We'll let you go and enjoy your whiskey.
I'm going to enjoy the whiskey. I'm going to retire from Islay geology presentations for a wee while, if you don't mind. I think you're all fed up with me. I think that's, and I did a Cambridge one.
I don't think that's true at all, actually.
I did a Cambridge one the other night. So yeah, I mean, I've pretty much done the gamut of the things that are of interest at the moment. So look at the recordings, and hope to see you in Islay, some of you guys, yeah.
Okay, well, just like to say again, thanks very much for doing this for us.
Okay, all right.
Really excellent.
Okay, I'll close the meeting. Okay.
Okay, cheers.
Bye.
Bye now. Bye-bye. Bye.
Bye. Bye. Bye.
End the meeting.